Today, we have Dr. Raja Vikhram Yoganandan sir with us, a member of IEEE, received the MTech degree in Control and Instrumentation Engineering in 2011 and the PhD degree in Electrical Engineering from Tyagaraja College of Engineering, Madurai in the year 2017. He is an assistant professor with the Department of Electronics and Instrumentation Engineering, SRM Institute of Science and Technology at Katanglatur campus, formerly known as SRM University. He was selected for the Council of Scientific and Industrial Research, CSIR, Senior Research Fellowship Scheme of the Ministry of Human Resource Development Group, Government of India in the year 2012. He was a gold medalist of the master's degree. He has authored 10 international journals and co-authored 4 international journals. His research interests include cyber physical power systems, power system stability and control, the modeling and simulation of large-scale power systems, modeling and simulation of FACS devices, wide area monitoring and control of power systems, intelligent control and system identification. He is a member of the IEEE Power and Energy Society and IEEE Control System Society. So we are very happy to welcome you. Welcome you, sir.
Thank you, madam.
And over to you, sir.
First of all, thank you very much, madam, for your introduction. Thank you very much, Jabarani, madam, for giving this opportunity to handle one of the session for SNS College. So, thank you once again. Shall we start, madam?
Yes, sir.
Madam, shall I share my screen from my end, or you will share the screen?
So you can share your screen, sir.
Okay. Can I able to see my screen, madam?
Yes, sir.
So first of all, I'd like to thank Jabarani madam for giving me this opportunity. So my title of the session is Cyber Physical Power System for a Secure and Sustainable Electrical Power Grid. So in this session, we are going to see how the power system is transformed into cyber physical power systems. So previously it is called as a smart grid. So now the current trend is it is a cyber physical power system. And the future of the power system is a cognitive grid. So this is the short introduction of this overview of the presentation. What are the topics I'm going to present in this session is first we'll see what is meant by power systems, and then what is meant by cyber physical system. So shortly it is called as a CPS. And then the third one, the application of CPS in power systems. So that is called as the third topic, cyber physical power system. And then fourth one, how the cyber attack and what are the cyber security measures in cyber physical power system. So that will be discussed in the fourth topic. And then the fifth one, very, very important, cyber physical power system test beds. So the sixth one, cyber physical system education 4.0. So that means what are the subjects you should know to understand the CPS in power system applications. And the last one, research areas. So if you are interested to do research in CPS application of power system, so what are the research areas are available in this domain? So first, introduction to power system. So generally there are four major domains in the electrical power systems. So the first one is power generation. So as you know that we are having a conventional power generation. So usually the conventional power generation means first one is a thermal power station, and then using hydro you can generate power. So and then a nuclear. So these are called as a conventional power plant. So this is the first starting point of the electrical power systems. Using this we are generating the power. And then the second domain is transportation, that is transmission of the power. So after power generation, so the second stage of the electrical power is power transmission. So in the power transmission, there are two types are available. One is a wired power transmission, that is a overhead line based power transmission, and another one is a UG cable based underground cable based power transmission. And then the recent technologies are wireless power transmission. So which one is the emerging technologies in a power transmission system? So after the power generation, power transmission, the third one is called as a power distribution. So generally the distribution which will be nearer to the load side, and then the last one is power consumption. So the power consumption is also called as power utilization. So these four are the major classification of the power systems: power generation, power transmission, power distribution, and the last one is utilization, or it is called as a power consumption. So in order to make the above four domains, so if the four domains to be function properly, we need the monitoring, control, and protection. So without monitoring, control, and protection, the above four domains cannot function efficiently. So the monitoring, control, and protection plays a major role in electrical power systems. So the entire domain depends upon this. We can call it as a heart of the power systems. So whether you can monitor the entire power system, or you have to be control it, or you have to be protect against any physical or cyber faults. So these three are the very important thing in the electrical power systems. So continuing with this, we will see the basic structure of electrical power systems. So I hope you most of them have seen this electrical conventional diagram. So the starting point is power generation. So the first one, power generation. So using a thermal power, nuclear or hydro, you can generating the power. So the maximum voltage generated by the generator is 11 kV or 33 kV. So that is the maximum voltage generated from the generator. So that voltage is stepped up by the step up transformer. So that voltage will be the level of 132 or 220 kV or 440 kV. So this is the voltage range of main transmission voltages in volts line. So currently India, the maximum voltage is 765 kV we are transmitting in the overhead line. And if you compare with the other countries, China and Russia, they are transmitting 1100 kV in volts line. So this is the difference of between India and other countries. So the maximum voltage of 765 kV is transmitting in a overhead line in India, and Russia and China, they are transmitting 1200 kV. Slowly we also will upgrade our infrastructure to meet the high power transmission. So after the first transmission system, the transmitting of the voltage level, and then the second stage is a sub transmission system. So here the 765 kV, 400 kV will be stepped down to the 230 kV system. So this is called as a sub transmission system, and then the sub transmission system voltage 230 kV is stepped down into 11 kV or 33 kV. So and then the 11 kV is stepped down into 230 volt to your distribution side. So this is the basic structure of the electrical power systems. So the next one is a conventional centralized power systems. So what is called a centralized power system means all the power generations are transmitted in a single pathway. So all the generations you are gathered in a common transmission infrastructure. So from the common transmission infrastructure, you are transmitting the power to the distribution. So this concept we are following still now. So in the centralized power system scenario, so slowly we are having the distributed generation, microgrid. Now we are using the nanogrid. So in addition to the microgrid, nanogrid, so the majority of the power sector in our Indian power sector is still we are depend on the centralized power systems. So we can see this hydro and then nuclear and then thermal. So the bottom one is renewable power sources, that is wind and then solar. So all the power generations are gathered or collected together and then transmitted in the transmission line and then forwarded to the distribution systems. So this is called as a centralized power systems. So the main drawback of this centralized power system is if any fault occur in the transmission side, the entire power system, the entire the residential sector or industrial sector will not get the power. So the modern power system. So previously we have seen this centralized power system. Now we move to the smart grid concept. So why it is called as a smart grid means the conventional power system is integrated with information and communication technology. So the conventional power system we are integrating with information and communication technology. So the internet and communication helps the power system to improve the monitoring, protection, and control. So that's why it is called as a smart grid. So you can see the smart grid. So in the smart grid, already the same nuclear, thermal, and hydro power stations are already there. In addition to the conventional power systems, we are having windmill and then renewable power sources. In addition to that, electrical vehicle also can be integrated. So from the grid, you can take the power as well as you can supply the power. So this what happened because of the main reason is the integration of information and communication technology. That is the internet is the main backbone for the modern power system. So that's why we are calling it as a smart grid with advanced sensors and actuators. So the next one is the modern power systems. So the modern power systems are consist of what? So the modern power systems are added with the smart home appliances. So if you take your home appliances, all the home appliances are integrated with advanced sensors. So based on the sensor, so it immediately act and it will improve the performance and then efficiency. So the entire smart home appliances will be full and full integrated with this advanced sensors. So it will track the amount of power, how much of power is spent, how much of power is delivered. Even it will switch off unwanted or unnecessary power wastage. So the second one is a distributed generation. So in every home appliances, mainly in abroad, they are using a small windmill and a small solar power plant. So it will generate the power for themselves as well as it will supply the power to the grid also. So the third one is India is well equipped with smart meters. So for the calculation of the amount of electricity usage and then electrical vehicle. So here also vehicle to grid or grid to vehicle, both of them are possible with this electrical vehicle and data collection. So using sensor, SCADA. Nowadays we are using the phasor measurement unit PMU, which is more advanced compared to the SCADA system. And then the next one is a decision making controller. So it is also called as a intelligent controller. So these are the components or systems which is integrated with the modern power systems. So the other components are also still available. So from the previous up to this, what are the challenges we are facing in the power system? So the first challenge is the power system is a strategic imperative. So definitely day by day, every technology is changing, but after a lot of decades, the power system is transformed. So that's why it is called as a strategic imperative. So even the vehicle have changed, the amount of tariff have changed, but the infrastructure, the electrical power infrastructure, it is not easy to change immediately. So we have changed the infrastructure of the power systems in the past few decades. So the second one is market prices and tariff. So the market prices and tariffs completely revised. Even today, you can see the paying of electricity bill is computed completely digitalized. So even no one from TNEB will come and take the readings from your end. So from there itself, they will take the reading and generate the bill for your consumption of the energy. So the next one is power quality and stability problem. So this is the another issue. So mainly due to the integration of the converters into the grid. So due to this, so there is a the issue in a power quality and stability problem. And then the next one is interfacing with another energies. So nowadays the power systems are designed to integrate with other types of energy apart from electrical energy. So that is the another biggest challenge in the present smart grid scenario. So the next one is a resilient power system. So unnecessary disturbances and unnecessary events are occurring in the resilient power system. So in addition to these technical challenges, the other challenges are forecasting the output. So the 2 decades or 1 decade before, we can able to forecast the output of this, but today it is very very difficult due to the uncertainty and then unable to detect the problem due to the cyber attack. And the next one is network flow. So the network flow is another technical challenge. So we need to maintain the technical, that is network flow within the specified limit. So the transmission limit should not be crossed or not be violated. And then the next one is a frequency. So the violation of frequency also leads to the blackout of the power systems and voltage rise and stability problem. So this is also a maintaining of the voltage profile. So within the particular limit, otherwise we have to face the voltage stability issue in the power systems. So these are the technical challenges in the present power system scenario. So the next one is allowable penetration of variable generation. So nowadays, you know that the solar power plant and wind power stations are integrated with the main power grid. So there is a certain limit of integrating this renewable sources. So if the limit is violated, the power system dynamics, the power system grid will be lose its stability and leads to the blackout condition. So that's what the coordination with the grid is very important while integrating the renewable energy sources with the grid. So the next one is a voltage coordination. So the voltage from your renewable energy sources and other type of power sources should be balanced with the grid supply or grid frequency. And the last one is the equipment limit. So all the transformers and then your productive relay, so and then your CTPT, everything should be maintained within the particular limit. So we have to be check that limit. So nowadays the power system control centers usually they will maintain the equipment limit. If it is violated or crossed the limit, again it leads to the some critical issue in the power systems. So now we have seen the different types of technical challenges, different technical challenges. So these technical challenges we are going to solve or we can face using the concept called as cyber physical systems. So the cyber physical system, you can take it as a new technology. So using this technology, we can face the previous technical challenges. So before CPS, we are dealing with only the smart grid. So after the cyber physical system arrived, or the evolution of the cyber physical system helps the power systems to make the entire system in a stabilized condition or in a safety critical conditions. So the simple concept of the CPS is the main background of our backbone of CPS is we call it as a triple C. So what is meant by triple C means computing, communication, and control. So without this, so no critical infrastructure will be exist in the world. So if you take any critical infrastructure, electrical power systems, transportation, water, oil and gas, even if you take a finance, military, defense, so the entire critical infrastructure depends on the triple C. So advancement in the computing, advancement in the communication, and the same advancement in the control. So and the academic point of view, we call it as a computing means department of CSE, communication department of ECE, and the control, so department of instrumentation and control. So the other department also, electrical means power systems, and then civil means the building infrastructure. So all this critical infrastructure completely depends on this triple C. So the advancement of the triple C makes the critical infrastructure in a more safe and stabilized condition. So the second point of, so the CPS concept is nothing but bridging the physical system with your cyber system. So that's why it is called as a physical components and then cyberspace, because cyberspace means it is completely a virtual one. So physical components, you can directly see any the physical components. So that is the main difference. One is a real, another one is imaginary. So cyberspace. So the idea of CPS arrived from the computing. So the function of the computing are sensing, analyzing, predicting, and understanding. So generally the CEC terms AI, ML, and deep learning, we are using this to sense the data and analyze and predict the so what will happen in the future. And then the second one, communication, mainly used for interaction and interface with the critical systems. And the third one is control. So after computing and communication, how we are going to control the system. So the control involves a evidence-based certification or a intelligent controller. So this triple C combines to form a intelligent and autonomous systems. So this is the basic introduction of the cyber physical systems. So always keep in mind that the backbone of CPS is this triple C: control, communication, and computing. So you can see you can aware of that. So 4G came, and then 5G, and then 6G. So the generation by generation, we are improving the accuracy and performance of the communication. So which will very helpful for the critical power systems as well as the other systems to make the system in a well safety critical systems. So the complexity of the CPS. So the main complexity in the CPS is the integration of cyber and the physical. So because cyber is full and full computer oriented and physical is nothing but a full and full, it is a core domain. So how to integrate, that is joining the cyber and physical. So that is the main challenging in cyber physical systems. So the knowledge of CPS should be known by everyone. So it is not only from the academic side, researchers. So even country policy makers as well as the system managers, even politicians, everyone should know about the knowledge of the CPS domain. So then only they can plan any activities or any scheme or any method they are going to adapt in the country. They should have the knowledge of CPS. So in general, CPS, you are going to integrate the physical space with the cyberspace. So that is the main concept of a cyber physical system. So can see this the basic representation of CPS. So the building block of CPS, it consists of triple C. One is computation, and then communication and the control. So these three are the background for the or backbone of the cyber physical systems. So here the physical system, I am talking about electrical power systems. Cyber system means a connection of or a joint communication, computing and control. So physical means it is a critical power systems, electrical power systems. Cyber means triple C, communication, computing, and control. So using this triple C, you can monitor and control the electrical power systems. So the cyber physical system combines the physical and cyber. So what is meant by physical system means any natural system. So whether electrical power system, even biological system, even your human system, human body is also a physical system. So transportation, banking, or any defense systems. So these are all called as your physical systems. So now the cyber system is communication, computing, and control. So you are going to integrate this cyber system with the physical system. So by integrating these two systems, we can monitor and control the system in a very, very efficient way. So that is the concept of a cyber physical system. So the cyber physical system, who developed this idea? So actually the CPS was developed or coined and introduced in 2006 by National Science Foundation, USA. So in our country, we call it as a DST, Department of Science and Technology. Like that in US, the research foundation that is called as a National Science Foundation. So it's introduced by the Dr. Helen Gill. So Dr. Helen Gill, madam, was introduced this concept in 2006 itself. So in 2018, our Honorable PM Narendra Modi sir allocated the budget of 3,660 crores for a cyber physical system. So now we are becoming a mastering power, or we are becoming a developing country in this cyber physical systems. So the next one is cybernetics. Before CPS, the term was called as a cybernetics. So the cybernetics means it is a combination of control and communication. So the control and communication only exist in the cybernetics. So after the integration of computer science, it is cybernetics is changed to cyber physical system. So the formal definition of CPS is interconnection of computing devices with the physical world. So that is called as cyber physical systems. So what are the components required for CPS? Means there are three components. One is sensor, controller, and actuator. So these three are the hardware elements required for the cyber physical system: sensors, controllers, and actuators. So using this, you can monitor the physical system and then control the physical systems. So this type of control system, we call it as a embedded control systems. So which is completely different from the conventional control systems. So why it is called as a embedded control system means by embedding the control in the systems, you no need to change or you no need to modify the program. So once it is embedded into the applications, you cannot modify or change the program. So whatever the changes will be happen in the systems, it will monitor and controlled by the embedded control systems. So the main advantage or main requirement of this type of system is we need a faithful model of your systems. If your model of the system is any flaw, we cannot develop the embedded control systems. So the control system, embedded control system means we need the another one is called as a embedded computing. So this is the main challenges in a embedded control system point of view. So in general, the control systems we are using the computing resources, which is not much required for the conventional control systems. But for embedded control systems, the computing resources, requirement of computing resources is very high. So on the last one is a formal verification technique. If you are designing any cyber physical system, it should be verified properly before it is deployed into the safety critical systems. Suppose you are designing the controller, embedded controller for any safety critical systems, it should be properly verified and validated and get certified. So then only you can able to deploy in the safety critical systems. So these terms are completely relevant to the computer science. So they will do the formal verification technique like a testing engineer, what they will call it in the CSE. So the CPS concept map. So this shows the brief overview of the cyber physical systems. So the cyber physical system, the top one, first we can see the bottom one. So the cyber physical system applications are, what are the different applications? You can use the CPS in electrical power system, military, defense, healthcare, and then consumer applications, communication, as well as for security. So you can use the CPS for all the applications. So that's what it is listed in the diagram below. So, and then what is meant by CPS? So the CPS are nothing but a feedback system. You can say this. CPS is a feedback system, and in that feedback, there are three feedbacks. So one is economics in the loop, and then human in the loop, and another one is environment in the loop. So these three are the feedback system with a loop in the systems. And another point is feedback systems are, the feedback systems are, it is a networked system, and it is also a adaptive, it is a predictive, robust, intelligent, and it is also called as a real-time systems. So after this, all the systems are, it may be a wireless sensing and actuation. So because of the advanced concept of transmitting the signal is a wireless transmission. So these systems are completely functioning as a wireless systems. So now you can understood that the systems are wireless systems. So we have the chance of a cyber attack in the existing CPS systems. So you see this. So cyber physical systems requires the cyber security. That means it requires resilience, privacy, and then security, malware attack, and intrusion detection. So since a cyber physical system is fully based on wireless, even wired also there, it completely projected to, or it will be exposed to the cyber attack. So that's what we need the cyber security. And another point is the cyber physical systems requires improved design tool and design methodology. So we can say this, the yellow color, it is a improved design tools. Cyber physical system requires improved design tools and design methodology. So from this, there are 3 points. One is specification, and then another one is a complexity management, and third one is verification and validation. So in the specification, we are have the different domains, subdomains. So you have to model the continuous system, model the hybrid system, and model the discrete system. So that's what it is coming under the modeling. It's because CPS is not a one domain. It involves the continuous, discrete, as well as hybrid. That is combination of continuous and discrete. And second one is scalability and complexity management. So it involves the composability, modularity, and synthesizing of the systems. And then the last one, verification and validation. So here the final stage of the cyber physical system, after modeling the system, after designing the controller, you have to verify and validate the system. So that is the last stage of the cyber physical systems. So do you have any doubt so far? Will I move to the next one? So shall I move to the next slide? So do you have any doubts?
Sir,
Okay, madam. Thank you. So the next concept is cyber physical power systems. So previously we have discussed the concept of CPS. So CPS means physical system is separate. The physical system is electrical power systems. Cyber system means it is a triple C: communication, computing, and control. So these two systems are joining together is called as a cyber physical system. Now cyber physical power system means you can see the basic structure of the CPS. So here the physical system, which is shown in the red color. So you can see this. So it is nothing but a plant processor system. So according to our application, it is a physical system is a electrical power systems. So the physical system output is sensed by the sensor. After the sensor, it is passed on to ADC, that is analog to digital converter. So here a sensor will be placed. Sensor, so sensor will be placed. It will sense the signal from the physical system, that is electrical power system, and then the sensed signal is passed on to analog to digital converter. So the analog to digital converter converts the incoming analog signal into digital signal. That digital signal is that digital signal is forwarded to the cyber system. Now the cyber system start processing the digital signal. So it involves the computation, or it involves the algorithm, software, or any coding. So that's what it indicates as a cyber system. Now the cyber system output is full and full in a digital. That is a digital mode, that is digital format. This digital signal is again converted back into analog, and then the analog signal is passed on to the physical system. So this is a basic structure of the cyber physical systems. So using this concept, we are applying to the cyber physical power systems. So you see this, the structure of the cyber physical power system shown here. So the red color represents the physical system, and then the blue color bottom represents the cyber systems. So in the physical system, for our application, electrical power systems, so generation, transmission, and distribution, and then the last one is utilization of the systems. So the first one, electrical systems. So the bottom one, the gray color band represents the control of the power system. From generation side, we have the control elements are automatic voltage regulator, exciter, and AGC, automatic generation control, and a power system stabilizer. So these are the components for generation side. And transmission side, fax controller, HVDC wind farm. And utilization side, it may be a demand side management or energy storage applications. Now what is the next stage? So the next stage is collecting the data from generation, transmission, and distribution. Now the data is collected and forwarded to the cyber system. So that is represented as the information signal. Now the information signal, sorry, actually information signal. So this red color represents the electrical signal. So it may be a voltage, current, power, or any kind of electrical parameters. So this signal is processed in the cyber system. After the signal is processed, the control signal is generated from the cyber system, again pass on to the physical systems. So this red color represents the electrical to cyber side, and the blue color represents cyber side to electrical side. So overall, your entire electrical power system depends on this communication, computing, and control. And then the last one is a power system simulator. So generally we will use the MATLAB to simulate the power systems. Sim power systems, I hope you are working in that area. And then for cyber system, there are a separate cyber simulator, NS2, for example, network simulator, or OMNET Plus. There's a separate simulator for cyber side. So when you merge the two simulators, that is called as a co-simulation. That is electrical simulation plus a cyber system simulation. This together of combining the two simulation is called as a co-simulation. So the formal definition of again CPS is, so any physical system integrated with communication, computing, and control. So that is called a CPS. But a cyber physical power system means in the cyber physical, the power system is integrated with communication, computing, and control. So that is called as cyber physical power system. So when you are merging the two different systems, because cyber is computer side and electrical is a core domain, what will be the occur? What are the problems will be occur? There are two problems. One is interaction, another problem is interdependency. So interaction means cyber system will affect your electrical system. Electrical system have some effect on a cyber system. So both will oppose each other. So that is called as an interaction. And second one, interdependency means cyber system depends on electrical system depends on cyber system. So that is called as interdependent. So one system depends on another system. These two problems will be a strong technical challenges in the cyber physical power systems. So events in CPS. So generally in power systems, we'll call it as a fault. It may be a single phase fault, three phase fault, or line to ground fault, or even lighting, whatever may be. We will call it as a fault. In CPS, it is called as a event. So the event is nothing but like a fault in electrical systems. So this fault or event may be occur in your physical system, or event may be occur in your software. That is a software issue or some error in your program, that is from software side. And last one, dependent events. So if any event occur in cyber, automatically it affect your physical power systems. And if any problem occur in physical power system, it will affect your cyber systems. So that is called as dependent events. So these three events are occur in the cyber physical power systems. And then very important characteristics of a physical and a cyber system in CPPS. So the first one is components. So in power systems, we know that what are the core component of power systems. So generator, transformer, transmission line, circuit breaker, productive relay. Of course, in cyber systems, there are only three. One is control systems, communication, and another one is computing. The second point is electrical systems are full and full continuous and dynamic behavior, and the cyber systems are full and full digital or discrete and very static behavior. And third one, usually we will model the system using this differential algebraic equations, and then the cyber systems are modeled by difference equations. And fourth one, in our system, energy will flow, but computer side, full and full information, that is data will flow. So they will talk about the data and we will talk about the energy. That means power and energy. So the fifth one is power grid model. So already we have seen the different types of modeling of the power systems. So here the information flow oriented model, that is a data flow model. So we know that how to model the system. You have seen in the IEEE 9 bus system, IEEE 39 bus systems. So we will call it as a one line diagram, but they will call it as a CSE will call it as a data flow diagram. And then the next one is a condition. So if your power systems to be stabilized means the generation and load should be well balanced. So that is the main condition in power system. But in CSE, what they will call it as a interdependent operation. So computer science, control and communication, there should be a balanced operation between these three. That is the condition for CSE. And contingency, according to our case, triple E, we will call it as a physical contingency, but computer science side, it is called as a cyber contingency. And then types of contingency. So line fault and generator outage, load outage. So we already we have seen this are familiar with the power system analysis types of fault. But in CSE, they will call it as a cyber attack, communication latency. That means a communication delay and a malicious control effects. That is a signal was misrepresented, bad data. So this is the another difference between the triple E and ECE, sorry CSE, and then stability and security. So according to us, power system security is an important one. For them, cyber security is another hot domain in CSE. And the last one is very, very important. Event synchronization. In our physical system, this is asynchronous. We cannot predict if one system is fault will happen means what will be the next instant we cannot easy to predict. But CSE they can easily predict if there is a one problem in the program, what will affect in the another stage. They can easily to predict that system. That is called as synchronous event. So the next one is a core idea behind the cyber physical power systems. So you can see this, the left side, the physical world, and then the right side is the cyber system. So the left side, energy, power and energy systems, manufacturing, transportation, entirely depends on the three terms, computation, communication, and control. So here what in our university, what we will do, we are making as a interdisciplinary. So all the students should have the knowledge equally in the all the three domain. So then only they can able to survive in the current industry need. So if the student is only having some good knowledge in control, but not having the sufficient knowledge in computer science or communication, means it will be very, very difficult. So we are training the students with some additional intensives. You should have a well-balanced knowledge in all the three domains. Then only you can able to survive in whether power system, transportation, manufacturing, or robotics, any applications. So that's what this is the main core idea of CTS. So the next one is cyber contingency and power systems. So the left side, it shows the conventional power grid. So it is a one-line diagram of the power systems. So right side, it is a cyber system. The EMS represents the energy management system. So as the symbol indicates, so from the left-hand side, you are going to measure the signal or status of the power grid. So the measure. So using CTPT, you are going to measure the current and voltage, and then this quantity, this data is forwarded to a cyber system, and here the information is processed, and from the energy control center, again, it is forwarded to the electrical power grid. So you can measure and control the system. So left hand side, full and full energy will flow, and then right hand side, the full and full of data will flow. So these two systems are completely different. So now the problem is how to quantitatively evaluate the contingency. Suppose if any problem occur in the physical system, power system, it will definitely affect your cyber system. Suppose if the any problem occur in cyber system, definitely it will affect your physical power systems. How we are going to identify, how to find out that? So that is the main challenge in the cyber physical power systems. So because you can see from this diagram, power system depends on EMS, energy management system, that is cyber system, and cyber system need the accurate data from the power systems. If any failure occur in any one of the system, it will be completely leads to the blackout condition. So interdependent and interaction. So the green color, the power grid, you can see that generation, load, power network, and switches. And then the bottom one is full and full of computer side, that is a PMU, RTU, energy management system. So both are interdependent. So if any problem occur in the physical side, or if any problem occur in the cyber side, it will leads to the blackout condition. So it leads to the blackout conditions. So far you can see this, the 8 bar 14, that is a 14th August, already one blackout occurred, that is a SC, state estimation function out of service. Another blackout occurred in Italy, that is a 28th September. So I have listed the years in the later slide. And then another problem occur in the China, that is a automatic generation control mal-operation in China. So these blackouts are occurred because of any problem occur in physical or cyber side, it will leads to the blackout conditions. So the only problem in cyber side, it will leads to the very, very dangerous situation. If a problem occur in cyber side, means we cannot easy to detect. So most of the blackouts are occur due to the cyber side failure, not from the physical side failure. So that's what we are urging or we are training the EEE students to learn about the cyber security for power systems, for power electronics. General cyber security for IT is completely different, but for cyber security for power system is a completely a operation technology based. So this was the interaction mechanism in CPS. You can see this, the left side power systems. Actually, it is a WCC 179 bus systems. So practically, the system is completely monitored. So the system is completely monitored by the cyber system. So with the help of the cyber system is the help of the cyber system only, they are maintaining the stability and security of the system. So the left side power system covers the 70% of the US. So actually this power system WCC, this 179 bus system is a 70% representation of the United States of America. So we are modeled the system, and using the cyber system, we are monitoring and controlling the systems. So the next one is what are the challenges? So the disturbance on cyber part result in the very dangerous situations, or it may create a risk in the physical systems. So in order to avoid this, we need to develop a mathematical model. So it should combine both the physical as well as cyber. Then only we can have some a good prediction or can have a good control over the electrical power systems. So again, same it is illustrated here. So the top one green color represents the cyber system, and then bottom one physical system, generation, transmission, and distribution. So the bottom one you can see this power system analysis. So so you can see this power system analysis. So in the power system analysis, we have seen different types of analysis, a Newton-Raphson method, Gauss-Seidel method, so which is very, very conventional and more practiced. But what we need today is we have to expand the power system analysis to cyber physical analysis. So whenever you are doing the load flow analysis or any type of analysis, you should not stop up to the electrical oriented only analysis. So in addition to the power flow analysis, you have to perform the cyber side analysis also. So that's why it is called as a cyber physical analysis, cyber physical modeling, or information and energy flow. So generally, we will model the system and simulate the system. We will see only the flow of voltage and current or power, that is a tie line power. But in cyber physical, we need to see the data flow also, whether the correctly the data is flowing or there is any lack of a data flow or any discrepancy in the data. So that's why it is called as a cyber physical analysis. So cyber physical analysis can see that the bottom one power system analysis. So this power system analysis, we are well versed already with the power systems. So we have to be improved towards the cyber physical analysis. So in order to get the knowledge in cyber physical, you have to strong in the knowledge of information processing. That is data analytics, data processing, and data science. So we need this kind of topics so that we can have a strong knowledge in cyber physical analysis. So the goal is how can we expand the current power systems modeling approach for a cyber physical systems. So first of all, it is not a easiest one. After developed the model of a conventional power system, you have to move to the next stage of cyber physical modeling. So we had to more knowledge on the cyber modeling. So I will show one diagram how the cyber physical modeling of the power system can be done in the present electrical power system scenario. So I request that if you are a triple E means, so I hope all the students are attending, most of them triple E. So don't feel that we are having a triple E as a core domain. How can we secure the job compared to CSE? So the problem is if you are not upgraded in the software side, so we cannot come up in this domain. So the electrical and computer engineering plays a major role in the upcoming period. So this shows the cyber physical power system model. So the top one is a matured one. Already it is fully matured. You can see this matured field power grid model, a node branch equivalent model. We have studied a lot of things like Kirchhoff current law, voltage law, and then superposition, Maxwell, whatever. Maybe you have studied different types of theorem. So in addition to that, what we need means the bottom one, information oriented modeling. So we need the information oriented modeling. So that is called as information flow oriented network. So which is the emerging topic in this electrical power systems. So information flow, information mapping, as well as device connections. So the top one is generation, transmission, distribution, and then the bottom one is the challenging of identifying, that is tracking the path of data flow, how to manage the data, and how to control the data flow. These two systems joined together is called as a cyber physical power system model. So it shows a simple coordinated secondary voltage control. So left side, the power system is nothing but it is a IEEE New England 39 bus systems. So the left side, it is a IEEE 39 bus system. So you can see this, there are 6 areas, A, B, C, D, E, F. So there are 6 areas. So A and B, C, D, E, F. So these are nothing but the areas in New England systems. Now you can see this one of the area, that is the area E is modeled in the cyber system side. So in the E system, it consists of 2 generator G33 and G34 and 2 transformers. So S20 and S19. So from this generator and transformer, that is we are measuring the data. That is the first stage. That is PQ and voltage. So that is the first stage measurement. After the data is measured, the second stage is local data compilation. And then we move to the third stage, that is the data uploading and then data compilation and then the decentralized decision. That is a controlling action is happening in decentralized way. And then the sixth stage is command issuing. That is you are finally sending a control signal, and then this final control signal is again fed back to the electrical power systems. So this is the a simple example of cyber physical power systems. So hereafter, if you are modeling or focusing only on the power systems, please focus on the another 50% of cyber systems, and then integrate the two systems. Then only you can see the full secured model of the electrical power systems. So so using this, we can able to monitor, control, and protect the system in an efficient way. But what is the main problem in the system is, in the cyber side, there is a chance of cyber attack. So anyone can attack in the data that is flowing from cyber system to power system side. So the cyber attack is a major issue in the cyber model of secondary voltage control. So the next one is a mathematical model of the previous secondary voltage control. So the top one, physical world energy flow equation. So the after the cyber physical world is over, you can see this. So the top one is electrical power systems. So the next stage is physical to cyber. So that means a continuous domain is converted into discrete domain. So the data will be entered into cyber world. From the cyber world, again, the data is converted from digital to physical. So this is a closed loop feedback control system. So it will measure the signal from the electrical power system, and the control signal will be issued to the electrical power system from cyber systems. So the mathematical model is represented here. So we need to monitor the state of the two systems. One is electrical systems as well as the computer science side, cyber state systems. So the state information is very, very important in this case. So how to simulate this? So already I told you that is a co-simulation platform. You can see this, the left-hand side, the communication simulation. So the left-hand side, it is a communication simulation, and then the right-hand side is electrical power systems. So these two systems are joined together. So communication system is joined with electrical power system. These two systems are joined together. That is called as a co-simulation platform. So for electrical power system, generally we'll use a MATLAB or a Dixon and Power Factory software or PSS bar E. So these are the softwares for electrical system. And for a cyber system side, network simulator, NS2, network simulator 2 and OMNET plus. And there are a lot of communication softwares are available. So we need to merge that is integrate the two softwares, then only we can get the co-simulation platform. So the next important topic is cyber attack and cyber security. So generally, cyber attack is a major issue in not only in a banking sector. So you have seen the day by day, the lot of news you can see in the news channel. So cyber attack happened, someone taken my money. So this is nothing but a small kind of a small level of cyber attack. So cyber attack in power systems are very, very high level. So everyone you know that the Russia and Ukraine war. So 2021 they have started attacking, but actually the war started in 2015 itself. So Russia launched the cyber attack against Ukraine in 2015. In 2015 itself, a war started, but the physical war started in 2021. So that's what the cyber war is, very, very dangerous and a threat to the country security. So cyber attack in electrical power system, transportation, water and gas, which are the very, very dangerous to the entire country. It will completely make the whole country to the blackout condition. So cyber attack, cyber security is an important one in CPPS. So that's what most of the research and development are focusing on cyber security side. So whether you may be interested in triply, someone interested in a dam protection, that means a hydro. So just imagine if the dam was completely hacked, means anytime they will open the valve. So immediately it will the immediate opening of the valve, it will makes the entire the district will be flooded. So these are all the vulnerability due to the cyber attack. So these are the history of cyber attacks in the energy sector specifically. You can see that 1982 itself a cyber attack happened. So that is the type of attack is code manipulation. But we have seen the computer in 1990s. That is 1992, 1993. We have seen the computer. But Russia launched the cyber attack. You can see that the country launched the cyber attack in 1982 itself. So 2015 itself, Ukraine was attacked. You can see the last one. So the 2015 itself, Ukraine was attacked, and 2021 only actually the physical war started between Ukraine and Russia. So this type of attack is called as a false data injection attack. So that's what yeah, if you are in electrical domain or any particular domain, it is the responsibility of it is our responsibility to protect our critical infrastructure from any kind of cyber attack. So you should not think like that. This is a computer science side. So our power systems we should protect. So these are the types of attacks. You can see that in 2019, Kudangulam nuclear power plant are also affected by this cyber attack. But this news is not exposed outside. So after a lot of years, only 2 to 3 years later, only it was released in the news. The Kudangulam power plant was attacked by the cyber attack. Because if the news was released immediately they will ask to close the nuclear power plant. So the global risk report. So according to the World Economic Forum, so the World Economic Forum is nothing but it is like nothing but a magazine. So you please subscribe this magazine. So you can, if you want to know the advanced technology or trends, they will publish one report. What's happening now? What is the employment opportunity? Everything they will discuss in the World Economic Forum. So the World Economic Forum, what they are talking about, telling about the cyber attack is the cyber attack is the next fifth largest going to be happen in the next 10 years. So if we are not prepared for the cyber attack, it will affect the whole electrical power grid, entire banking, military defense, everything will be spoiled. So that's what cyber attacks are very, very important in the day-to-day life. So the next one is cyber security. So cyber security means simply there are five concepts. So cyber security for IT is completely different. We are not following the IT security model for our electrical power systems. So what are the cyber security tips for cyber security methodologies for power system is first one, risk modeling and risk mitigation. So you have to frame that means you have to do the risk assessment. So what are the risks involved in electrical power system? Second one, attack resilient monitoring, protection, and control algorithm. You have to develop a algorithm that should be attack resilient. So previously we have seen the physical fault, three-phase fault, ground fault, line-to-line fault. In future, it will not going to happen. Even it may be happen, but percentage is very, very small. So we have to shift from fault to attack. So hereafter, we are not going to discuss with the fault, types of fault, three-phase fault, generator fault. We need to switch over from fault to attack types. So that's what the second one. Third one, defense against coordinated cyber attack. So the problem is you cannot get the attack from one country. So for example, Russia will attack against India, China will attack against India, Brazil will attack against India. So that's what a coordinated attack. So as a country, we should be preferred with many other countries, 3 or 4 countries, we have to be manage or we try to stop that attack. So the fourth one is advanced metering infrastructure. So this is coming from residential side. So all the meters, smart meters should be well secured. And last one, simulation models. All the simulation models should not be just like a MATLAB simulation model. You have to do the real-time simulation. So how it will happen, what will happen, what is the resultant effect, so how it will affect in the economic point of view. So that is the cyber security for the cyber physical power system. So how the cyber attack will happen in the power systems? It shows a simple block diagram. You start from the left hand side, you see this, the types of cyber attack. So these are the cyber attack, that is a denial of service, malware, and phishing attack. So this type of attack will be started first to enter into your SCADA, human machine interface, field devices, that is sensor, actuator, through your communication protocol. So first, the left hand side is types of attack. This type of attack enter through your SCADA, supervisory control and data acquisition. DCS also vulnerable to cyber attack. HMI, human machine interface, and then through different types of communication protocol. So once the cyber attack entered into this channel, that is, if it is entered into the SCADA, the next stage is it will move to the power system components. So that means AVR, and then your power system stabilizer, bar compensation, state estimation. So every functions, components, subsystems, entire will be affected by this cyber attack. So that is called as intrusion happened into the power systems. So after once it is enter into the power systems, the final thing is called as a physical system impact. That is, we will face the shutdown of the power, or we will lost the power transmission from the transmission side. So completely we will lost the economics. That means all the medical sector depends on the electrical power. If the power is lost for 1 week or 1 month, means just imagine the entire medical system will be is the endangered condition. Next, banking also depends on the electricity. If the electricity is completely blocked for a month, so it completely spoil the economy of the country. And military defense, so for all the applications, the electricity is the backbone of the critical applications. So that's what safety and securing the electrical infrastructure is a very, very important thing in the uh, present scenario. So this is a cyber security life cycle model. So the first step is prevention. So first you have to take the prevention from any kind of cyber attack, and then if any cyber attack happen, the next step is you have to detect the cyber attack. Third one, you have to mitigate the attack, detection, mitigation, and then I think so, and then resilience effect, and then forensics, and then the last one is deterrence. So the last one is deterrence. So we have to take the actions step by step. So first you have to monitor the systems if any cyber attack is happened or not. First you have to take the preventive measure. Suppose if the preventive measure is failed, means you have to take the detection measure. Yes, the cyber attack is happened to the electrical power systems. After once the cyber attack is detected, you have to start the procedure to mitigate the cyber attack. So after that mitigation, and then you have to follow to the resilience. So that means even system is affected, it should be come back to the original position. That is called as resilience. And then forensics. The forensics will help to find out the evidence where who launched the cyber attack, that involves in the forensic analysis. Last one, deterrence. So completely stoppage, or completely it will terminating the entering of the cyber intrusion into the systems. So that is called as a deterrence effect. So the taxonomy of CPS. So nearly there are 63 types of cyber attacks. So I don't know whether you have known the 63 types of cyber attacks. So day by day we are seeing in the news channel. So someone has sent the OTP, someone taken the information. So someone used the PAN card. So these are all the one type of attack, misusing the information. But practically 63 types, and beyond that, day by day the new type of cyber attack is evolving. The second is cyber attack detection method. There are 38 types of detection methods are available for your system to detect the cyber attack. And for mitigating, there are 23 types of methods are already available. And risk analysis, 8 types of risk analysis. And threat modeling, 10 types of threat modeling is analyzed. And for vulnerability assessment, 14 types of vulnerability assessment are there. So this is a free paper available in online. It is available in IEEE Explore. So I have written this paper, which is the starting point of cyber physical system. So the title of the paper is Cyber Physical Power System, a review on modeling, simulation, and analysis with cyber security applications. So it is a free paper. It is a open access. Suppose if you are interested to do research in cyber physical system, so please type this title in the Google. The paper freely available in the PDF format. Just to go through the paper, in the paper itself, I have listed out what are the 63 types of cyber attacks, what are the 38 types of detection methods, 23 types of mitigation methods. So every detailed manner it is available in this paper. So please see this paper and read the paper. And if you have any comment, you are always welcome, whether it is constructive or destructive comment. So cyber physical power system test beds. So the main objective of the test bed is not only to simulate, to assess so what is the effect of cyber attack in physical power system, and it helps to design a cyber security algorithm for the electrical power systems. So the types of test bed are there are only major two types of test bed. So one is non-real-time simulation test bed. Second one is real-time simulation test bed. So non-real-time means it's completely offline, and the real-time simulation means completely it is an online simulation test bed. So generally test bed is used to you can study and you can do the research. If cyber attack happen means what is the impact in power system. So if you are designing any cyber security algorithm, same thing you can test in the test bed. So whether your cyber security algorithm will defend the system or your cyber security will be failed or not. So everything we can test in the cyber physical power system test bed. So these are the future cyber physical power system test beds. So you can see this, there are different types of cyber physical power system test beds. So first of all, in India, there are two test beds are available. If you have time, you can please visit. So the first test bed is uh, available in IIT Kanpur. So you can, if you have time or if you want to, if you are interested in that, please visit IIT Kanpur. So they are having the cyber security test bed for all the applications, including electrical power systems. So cyber security test bed, that is C3I, and another test bed is available in Bombay. Actually, another test bed. So this is another test bed, cyber physical power system test bed in IIT Bombay. So these two test beds mainly for our Indian scenario applications. So they have the excellent infrastructure. So you can learn more about the types of attacks, security, and if you are interested, they are ready to collaborate with you. Like that, you can develop more algorithm using this test bed, and you can see the a practical experience point of view with the electrical power systems. So these two test beds are fully sponsored by the government of India. So it is anyone can access this test bed and it plays the test bed for academia. Sorry, it is used for research purposes. So all the countries they are focusing their R&D activities in cyber security. So you can see this left hand side, Europe, Asia, and Australian continents test beds are available. So in India, there are 2 to 3 locations test beds are available. IIT Bombay and another one is IIT Kanpur. And then North America, you can see this for every state they are having one test bed, cyber security test bed, because of in future the cyber war is the major issue. So 2020 in Corona we faced the bio war, and then we have seen the First World War, Second World War, that is the physical war. Again 2021 we are facing the physical war. In future completely it will be a cyber war. So that's what US are spending more research and development activities in how to prevent the cyber attack. So the next one is education. So if you want to have more knowledge in CPS, what are the subjects you must study? So actually 21st century means it is 100 years, 2001 to 2100. So we are calling this century as a CPS education. So why it is called a CPS education means it is a interdisciplinary subject. So not only EEE, not only ECE, or not only computer science. So you have to integrate these three domains, that is called as CPS education. So the last section is the education point of view. So it is our responsibility of the teachers to create the graduates to make it as a interdisciplinary one. Then only they can able to meet the future industry needs. So what are the subjects you have to need? I just go to the subjects. What are the things you need? So the main concept is first you need the fundamental concepts of computing. Basic computing concepts everyone should know. Second one, computing for the physical world. So in our university we are having the computing lab for first semester and second semester for all the engineering discipline. EEE, E&I, everyone will undergo this computing concept course, and then computing for the physical world. And then third one, so definitely you also, I hope you will have the discrete mathematics and max 1, max 2, max 3. So normal max 1, max 2, max 3 in addition to the discrete mathematics also there. Fourth one, sensor, background, actuator. Another one, basic computer science and computing. And then the last one, modeling of the systems, how to model the entire systems. And then last, sixth one is CPS system verification and validation. So these are the basic foundation for creating the CPS curriculum. So what are the research area? So the research area is mainly for those who are those who are a research scholar. So the main research areas, if you are want to do research in CPS, means the first one is developing the model, mathematical model, continuous model or discrete model or hybrid model of the CPS. Second one, safety point, security, privacy, resilience. So this is another domain or challenges in the CPS systems. Uncertainty. So and this diagram shows that the challenges of working in multidisciplinary area. What are the challenges in CPS? We can see this, it is a small computer or it is a network, it is advanced manufacturing. So it is not a single domain, it is a mixing of multiple domains. So that's what a CPS is very, very difficult for the students and the faculty to take up the research. So the final need for CPS research is still we are in the developing stage, and there are a lot of barriers in there. So okay, there are a lot of single subjects are available. Control systems and digital circuits as a single subject is available, but all together we need to study, that is called as a cyber physical system. So the final research area is, if you are continuing with, if you are want to do research in CPS, means modeling. Modeling is the hot topic in electrical power systems. Second one, simulation, that is a co-simulation. Third one, cyber contingency. Cyber attack alone is a big research area. Fourth one, cyber security is another hot domain in cyber physical power systems. So conclusion, so CBPS, it is a new technology for electrical engineers to achieve the high efficiency and performance. So recently, modeling, simulation are giving a high attention in the electrical power systems. So please focus on the modeling, simulation, analysis of the electrical power systems. The CPS leads to the more efficient operation because of this communication, computing, and control. And then the area is day by day is exponentially growing. So not only in electrical power systems, in other domain also, CPS plays a major role. So if you are interested, please collaborate with us. You are always welcome. We are seeking a good interested student or a PG student or research scholar. You are always welcome to join us in our research group. So these are my publications. So the 4 publications, I will share the slide to Jabarani madam. So you can get the slides from Jabarani madam. You can, if you are interested, you can read the paper. And thank you for your patient listening. Thank you.
Thank you so much, sir, for giving us detailed information about CPS analysis, various cyber attacks, right, and what are the subjects we need to know for doing our research work in CPS. Thank you so much, sir.
Thank you. Thank you.
Sir, can you just tell us, is there any possibility to use big data like computing in CPS?
Yes, ma'am. Definitely, there is a scope for in a cyber physical power system. So, big data, we need to analyze that data from the distribution side. So, currently, we are focusing on how to control, that is demand side management and transactive control side. So, these two applications mainly depends on the big data analytics. So, demand side management fully depends on the big data analytics from the distribution side. So, you can focus on the distribution side big data analytics.
Okay. So where to get this data, sir? Is there any forum where
Yes,
from where
madam.
we can
Actually,
get the
IEEE have started the IEEE data port. So you
okay.
can get the data from that IEEE. So we
Okay.
can see this. Just can able to see my screen, ma'am?
No, sir.
Can you able to see my screen, ma'am?
Yes, sir. Yes, sir.
Madam, actually, you can just search IEEE data port.
Okay.
So you IEEE data, separate data sets for all kind of data sets fully available. Even Indian government also have a separate portal, Indian data. So data sets. So particularly not only for electrical power systems, any type of data sets available. IEEE gives a more technical data relevant to power systems.
Okay.
So you can
Okay,
see
sir.
in the IEEE data port separately it is available. Okay, ma'am.
Oh, thank you, sir. Thank you, sir. Participants, do you have any queries? If you have queries, you can very well raise it. Mani, sir?
Yes, ma'am.
யாராவது ஹேண்ட் ரைஸ் பண்ணிருக்காங்களா சார்?
மேம் மைக் எல்லாத்துக்கும் எனேபிள் கொடுத்துருக்கு மேம்.
Okay. Participants, you can directly raise your queries.
Yes, ma'am. I can see one raising hand, Bharadam Murali.
Bharadam, sir.
Bharadam, sir? Okay. Any other questions, queries, participants? If there is no query, then we can close the session. Sir, again, I extend my heartiest thanks to you for giving us a good lecture on this CPS. We wanted to hear from you. You have published a lot of papers in that. So from an expert, we wanted to learn. Thank you so much, sir, for sharing your knowledge and expertise with us. Right, sure. Many will approach you, right? Many will approach
Yes,
you.
yes, ma'am. I have seen some comments and Nanda Kumar also raised the hand. So actually, ma'am, shall I read that question from the comment section?
Yes, sir.
Actually, power system modeling analysis, power system MATLAB modeling analysis only available. Any other software tools in power electronics? Actually, I am very sorry to say this. I am from full and full power system side. You can for power electronics. I'm not a so on the side power electronics side வந்து என்னோட scope இல்ல மேடம். So who raised this questions? Nanda Kumar Venkatachalam. So I'm sorry to unable to answer this question. So for my focus is fully on power system applications. So power electronics, definitely there is some advanced software is available. If you want to get the knowledge in the power electronics side, means you can contact Jagabar Sadik from our EEE department, SR Ministry EEE department. So that group is working in power electronics side, software, full and full software in a power electronics side. So please, Nanda Kumar, you can please contact Jagabar Sadik, sir.
Okay, sir. Okay.
Here's another question. Definitely, I share the PPT. Someone asked to share the PPT, sir. Yes, I shared the PPT to Professor Jabarani Angelini, madam. So you can contact me.
At the end of the program, we will be sharing the PPTs with you, right? You can refer. I'll be giving you the link for the PPTs. You can utilize it.
So I think, okay, ma'am. So is there any questions? Okay.
Okay, sir. Thank you so much,
Okay.
sir.
Thank you, ma'am. Thank you, ma'am. Thank you.
Thank you, sir.
Thank you, ma'am.